This is Dave Thomas. This video is an overview of the printed circuit board that I designed for using in the transmit pole for the NAPA EGS. The board consists of a very long and skinny one. It's 12 inches long. Um, Previously, I've implemented this with using just 4-inch boards with connected by ribbon cables because 4 inches is the longest that my free tool could use. But I started using a new open source tool, KiCad, and it has no restriction on the length of the board, and I found it much nicer to use than what I thought. This board has infrared LEDs on both sides. The bottom side, this is something new. I need to have components populated on both sides. On the top side, we see them. They shoot both directions. Just take a look at it. A little bit more there, and then on the top, this little thing here is a DC to DC converter. It's actually adjustable for development uses, so we can actually control how much transmit power we have. We can really this guy can put out almost 10 times more power than the FarmTech poles that we're using today. Of course, that comes with the expensive battery, so I want to just adjust this and find out what we really need in actual use. There's the processor on board. It drives each of the four gate MOSFETs that in turn drive the LEDs. This is the programming header. Here's some circuit needed to measure the battery voltage, so this can monitor the tool battery, the pluggable tool battery, and give an indication when the battery is low. The entire thing is going to fit on aluminum strip. There's a slide inside the square pole. We can't mount this. In my old design, I mounted this board directly on the back of the tube, on this aluminum bar, than that on the tube. But we can't do that here because we need the right spacing on the LEDs. So instead, I'm using these snap post connectors. And as you can see, they keep them spaced. This spacing this is designed so this is exactly halfway in the middle of the rectangular tube that I'm using. So there's each one of these 12-inch boards has four transmitters, and that's just to indicate that I have to actually have a hole in the aluminum strip for the bottom side emitter to transmit through and out. And the last view here is just that takes 3 of these PCBs plugged together. I've gotten a quote on this for the total assembled cost. I don't remember what it is offhand. I'll report that to you. So it's ready to go. I haven't tested. I just got the printed circuit boards in yesterday. I'm going to build up my first one today. And if that looks good, I'll just need to get some feedback, seeing if there's interest, and maybe we want to have some just fully assembled ones built assembled for complete pole assembles for use with NAPA. Thanks.